Hello viewers, welcome to my channel. Here we have a question on circle theorem. When you look at the question, the approach towards getting to finding x here may seem so difficult. When you look at it, you can pause the video and give it a try, having watched our previous video on circle theorems. Alright, so let's delve into finding the solution to angle x. How do we approach this? I will give you some simple theorems that can actually help us in finding angle x as we have it there. All right, some of the theorems that we need to be conversant with include the theorem that talks about the angle subtended by diameter. Recall when you have the center O in a circle, the line that divides the circle into two equal parts or passes through the center of the circle is known as diameter. So any angle subtended by diameter to any part of the circumference is always what? 90 degrees. I believe that one is established. It's going to help us here. When you look at the question, you see from the diagram, you have a triangle, as you can see, because that is triangle. All right, so, and in that triangle, we have a diameter. That is the line that passes through the center of the circle. That is what we call the diameter. So the angle subtended by the diameter, as you can see, the angle subtended by diameter from here to the circumference is always 90 degrees, just like we have it here. Then another important theorem that we need to look at is the one that talks about angle on the same segment. It's quite hidden from the question. Looking at the diagram, you may not be able to see it quite clearly. And the theorem talks about the angle on the same segment. Any angle coming from this segment, this is a chord. So a chord divides the circle into two segments, of which we have the bigger side of the circle as the major segment, and the smaller portion here shaded is known as the minor segment. Angle on the same segment is the angle subtended by an arc of a circle. As you can see, the rotation from this point all the way to this other point is called the arc of a circle, while the straight line between two points on the circumference is known as what? The chord. The line segment joining any 2 points on the circumference is known as a chord. All right, so having it this way, any angle subtended from this chord going to a particular segment, as you can see, we're talking about this segment. All right, then another angle subtended from here as well. We can say that angle leading from this particular segment always give us equal angle on the circumference, in as much as both are coming from the same segment, as you can see here. So that is to say the angle subtended by this chord from this segment, they are always equal. And we call it angle from the same segment, in as much as the feet, the two legs of that particular line segment, the angles must be subtended from those 2 points. As you can see here, this angle is subtended from these 2 points towards this direction. So let's call it A here. Then it's being subtended from this same point to another direction within the same segment. Let's call it B here. If you have another line still stretched from the same 2 points to the same segment, all these angles are judged to be equal. We call them angle on the same segment. An angle on the same segment is equal. They are equal in measure. As you can see, A is equal to B is equal to C, as you can see here. So we call it angle on the same segment, or angle from the same segment, as the case may be. All right, so we are going to be seeing something like that here. I don't know whether if you can figure it out from this larger shape. Let me give you some time to look at it and see whether if you can figure out angle from the same segment from this diagram before we now delve into solving the angle X. Can you see it? I believe someone must have seen it. Look at it from this angle. This is a chord, this is a segment, the rest part of it here is called a segment. The angle that is being subtended from the feet here, the two legs, you see how it goes. That's angle here. And there's another angle coming from that same position. That's the angle we have here. So you can see that these two angles are angles from the same segment. As you can see, the angle here and the angle here. They are angle from the same segment. As you can see, the leg here. Whenever you are solving questions on circle theorem, always observe these diagrams very closely. Then you'll be able to find some hidden facts that will be able to help you to resolve any problem. I believe with these important tips I've given you, you should be able to solve this question. Remember, the angle that is being subtended from diameter is always 90 degrees at the circumference. That is to say, it forms 90 degrees at the circumference. Then angle coming from the same segment, as you can see here, you have a chord. Angle that is being subtended from the same feet, as you can see, to the circumference on the same segment. The angles are always equal. A is equal to B is equal to C. All right, so that's exactly what we need to know before resolving this particular question. Now let's go into solving the question proper. Looking at the question, let's find out the particular angle that we can find first. Here we have different kinds of triangles. How many triangles can you figure out from here? We have this triangle. We have another triangle. Then you have another triangle, as you can see here. So those are the triangle, and the bigger triangle, the biggest of them all. All right, so looking at it, which one can we actually figure out first? Consider this triangle, as you can see. Consider the triangle. Consider the triangle. Let's label it A. Sorry, the marker is not bringing out the right up. A. Consider this as B. Consider this as C. Consider this as D. Then this point as E, as the case may be. All right, so look at this direction now. The shape A, C, D is a triangle. A, C, D is a triangle. And we have this particular portion here given, that is 20 degree. We have this portion given. So we can actually find the value of the angle that is being subtended here. The angle that is being subtended here, we can find the value of this angle from the triangle. And we know that the sum of the interior angles of any triangle is equal to 180 degrees. That is to say, the angle that we have here plus 20 plus 27 will always be 180 degrees. All right, so to do that, we have to simply put it this way. C, we are considering this portion as C. That is the angle C plus 20 plus 27 is equal to 180 degree, and that is the one we call sum of the interior angles of a triangle. Now to go further, we have C plus this will give us 47 is equal to 180. All right, so to solve further, we collect like term. That will now be C is equal to 180 minus 47. So what we have as the value of angle C here, that will give us 133. 133 degree. That is the value of the angle that we have here. 133 degree. Now, having found the value of this particular angle, which other one can we possibly find next? I believe we can find this particular angle here. That is by considering angle on a straight line. Recall, what we did in our previous videos, where we talked about different aspects of angles. Whenever an angle is being subtended within a semicircle or within a straight line, the angle formed on that straight line is always 180 degree. We call it angle on a straight line. If, for example, I have A here, I have B here, that is to say A plus B will always be equal to 180 degree. That is angle on a straight line. Now let's take a look at how to find that particular portion here. Let's label this place as Y. Let's label it as Y. So to find the value of angle Y, we have to say Y plus 133 is equal to 180 degree. You know the reason? That's angle on a straight line. Angle on a straight line extend from here all the way here. All right, so to do that, we have to collect the like term. That will now be Y is equal to 180 minus 133. And Y will now give us 180 minus 33, 133 rather, will give us that will give us 47 degree as the value there. Now we've gotten this place to be 47 degree. Do we actually know what this place is? Recall we talked about angle from the same segment. Angle that is being subtended from the same segment or from this chord, the 2 feet of the chord all the way here. That is this. So say the angle here is equal to the angle that is formed here. So since we have this place as 47, this place will of course be 47. That is angle on the same segment. Now, having found this particular portion, can we actually find this place? Do we know what this place is? If you recall the diagram I gave not long ago, that's the angle that is being subtended from the diameter, always from 90 degree at the circumference. If you can still remember this. All right, so following that same format in getting this particular position, can you guess what this place is? This is the diameter. This angle that is being subtended from diameter is always 90 degrees. So that's to say this place is 90 degrees. All right, so what is next for us to find? Remember, our destination is to find the angle X here. That is our destination. And to do that, we have to simply consider a certain triangle. I don't know whether if you can see the triangle AEB. Triangle AEB. That's right angle triangle as we have it here. So to obtain that, we have to sum up all the interior angles of this particular triangle AEB. So to do that, we have to add up everything that we have. We have to add up this, which is 20 plus x, plus 90, plus 47. That will be able to give us our correct solution. So to do that, we have to say 90 plus, let's give some demarcation. All right, so 90 plus 47 plus x plus 20 equal to 180 degree. That is sum of angles, interior angles of a triangle. As you can see, this plus this plus this, that will give us 180 degree. So summing this up, that will give us 137. Okay, let's sum it up with 20. This is 137. 137 plus this will give us 157. 157. That's 90 plus 47 will give us 137. 137 plus 20 will give us 157. Then plus x is equal to 180. All right, so to then get our x finally, that will now be x is equal to 180 minus 157. What will be the final solution here? The final value of x would then be 180 minus 157. That will give us 23 degree. And that is the value of this angle. As you can see, the question seems so hard at the beginning, but now it looks quite simple. It's just for you to be able to figure out some of the theorems, important theorems that are being captured in that particular diagram. As you can see, we have the one of a semicircle theorem. We say that the angle subtended by diameter is always 90 degrees at the circumference. Then we look at this angle from the same segment are always equal. So as you can see, the angle that has been subtended from these 2 points to the circumference here, 47, is always equal to that of the next one from the same segment, 47. So if here is 47 there, here must definitely be 47. But we started by finding 133 degree as we were given this in the question and this one as well. Then we have to do sum of angles in a triangle. That will be 20 plus 27 plus angle C. We judge this to be angle C. So after finding that, we have 133, which is what we have here. Then we now went further to use angle on a straight line to find the angle here, which now resulted in knowing what this place is all about. Then from there, we're able to now say this plus the entire thing here is equal to 180. And finally, we now find the value of x to be 23. I believe this is quite simple. Please don't forget to click on the subscribe button as we continue to roll out more videos to make mathematics easy and simple for you. Have a great day ahead. Bye.